Hey guys, how are you? So we're about to make some chips. I don't know if the chips are gonna come out of the material or the end meal. So I set up the piece of steel or whatever, you know, the stock that we're gonna try to get that griddle out of. And I don't know if you remember yesterday, I kind of show you a milling process. I was gonna be holding it here on the vices and kind of mill everything and come down here all the way to a 1/2 inch, finishing my pocket, all the pockets and drilling inside. So that didn't work because I forgot my vices. They don't reach 8.5 inches. So I did the whole camming and all that, thinking that I was gonna able just to hold it here, 200 thousandths on the side. So bad idea, bad situation. So what's going on is, let me get the tape. My vices, they only get around 8 1/8, somewhere like that. So what I'm gonna do, because I don't have any other way to doing it that I know of, I'm gonna go ahead and mill 2 recesses on each side of the vise. Like pretty much I got on this one here, I got one of those recesses. This is my first vise. You see that thing has been through hell. I already put a 3-inch end mill on it, and that's my first one. Or this one here on the brothers. No, it was this one. This one was first vise. I drill it here. Okay, so you see I got a recess on it. So what I'm gonna do is I'm gonna put them 2 vices on the machine, line them out the best I can, and I'm gonna run an end mill on the 2 sides in order for me to have enough room to fit that that plate after I rough and finish the outside faces on X axis. And I gotta reach out all the way to, let me measure this here. So I gotta reach out all the way to, what's going on here? On my y-axis I got 8.2677, so 8 1/4, a little bit over a quarter. So if I just mill all the way to whatever them faces are, I'm gonna need 8 1/4. So and if I got 8 1/8 over there, I really just gotta do, you know, some little bitty touch on then on those pieces on the vise, and I'll be able to hold that piece on the first operation. So my first operation is not gonna be, like pretty much milling all this pocket and drilling and all that. My first operation is gonna be the outer contour, and not the whole outer, just, you know, the 2 long side, so I can hold on the vise and then hopefully just finish everything else on them vices. So that's it for now. That's the strategy that I'm gonna be using. I'm gonna give you an idea or maybe a tip, and this always happens to me, and after I do it I have to redo it again. So I'm sitting on, see these blocks that I got down here, they're really tight now, but let's say, like I always do the mistake at the beginning, if I put shorter clamp downs or whatever, if I put them shorter, or I sit them on top of the, let's say this area. So if I put them, let's say if I pull it back a little bit and put it on the middle, believe it or not, it's not gonna create any force on the whole plate. So pretty much these blocks, they're gonna be loose. So right now it's right on the edge of the block, so it's not pushing. Whatever is pushing in is being held by that. So if you ever put this together and your blocks or whatever you hold in here is moving, you got to find a way to get in with your clamps down and make sure you kind of put some pressure on the plate or whatever you're holding in order to kind of sit on this. Like I said, if I run this one back a little bit and start pushing on the middle of this 246 block, it's not going to create any pressure on the metal, and that's going to be just, you know, loose over there, and it might walk on you and you hit it with the end mill or whatever. So make sure you move it in the most you can, and the better will be just like this one, kind of be on the very edge of where your 246 block or 123 block or whatever block you're using, right on the edge of it. It will create enough force to hold your middle blocks in. That is something I always start the wrong way and end up doing it the right way. Alright guys, I'll be back with you. So I'm gonna do some milling over there. Just gonna be good because I'm gonna learn a little bit how my 10,000s a 150 a minute or whatever inches it's gonna be doing on those two walls, and then we'll see how it would go on the other operations. All right, bye. I'll be back. Okay, so I'm gonna add this part too, and there's another tip, just like the one I just told you on them clamps or whatever. So when I'm milling and I got something on the metal in between one operation, in between two operations pretty much, which is that clamp over there, so I know my rapid height is gotta be higher than whatever this is. You can always get a tape measure, and that's what I do. I'll lift the tape over there. Let me go get the tape. So you always get a tape measure and try to find your highest spot. Let's say I'm measuring here and I'm around inch and I don't know, inch and a half. Let's say 3/4, right? So you definitely, your rapid planes, they gotta be, even if you're just gonna work here in the middle, make sure your rapid planes, they are higher than that. Because I mean, you could know, but just to be sure, make sure even if you're working on the metal, you measure your highest part of your setup and do your rapid heights. Make them higher than whatever your setup is, because you'll break some stuff. And this is how I do. So so let's say I come here to my, I'm gonna start, let's say the whole machine setup or whatever, it's gonna be on a 2-axis. I'm just gonna be milling these two sides. Hope you see it over there. These two lines are the two faces of that plate. So the first thing I do, I look into my rapid planes up here, over there, and if I know I got inch and 3/4, which I only had inch and a half, I'm gonna put 2 or 3 or 4. I mean, it doesn't hurt to have more, pretty much. So I'm just on 2 inches, and besides that, you make sure, like I said, your rapid planes are higher than anywhere on your setup. Anywhere, it don't matter where you're working at. Make sure they're higher than anywhere on your setup, even places that you're not even gonna be machining. Make sure you're higher on your rapid planes. That's one thing. And the other thing is, after you post it, let's say I come here and I'm gonna post this, then you're gonna start looking for your C movement. So like right here, I got a C.1, and then after C.1, that means my C axis is gonna come down to C.1. So 100 thousandths from the surface, or from 0 on C, and then here I see it 2 inches. It's Z2. That means my rapids, they are really posting on my G code, because sometimes I had it on this program where you can put something here. And if you remember, I got a video on it. You remember that video that starts me breaking and the Senate drill or whatever, that it put a 99 instead of 98, so it didn't cap to rapid planes. It stay on feed planes. So, and I selected to stay on, you know, to jump over that, but it was using a 99 instead of a 98. So you got to make sure your C-axis is gonna have enough clearance for whatever your setup is, and make sure once you set it on your machine setup, then you come to your G code and make sure you see it over there. Like right here, we can see I got a Z2 right there. Hope you see it. So that means my C is coming up 2 inches after it done the first cut. So after it done the first movement, it went up to 2 inches to come back to the place, which is pretty much what is showing here on the CAT program. So it's showing that it's gonna go up 2 inches, these red lines, and then it moves to the other place. So that's one thing I'm gonna add here on the video. It's gonna get a little bit longer, but this is really important. Make sure you do it on your machine setup, but you also see it on your G code. I mean, posting and drawing and setting up is there are many different things. So make sure you draw it the right way, you set it up the right way, but you also see it on your posting. All right, I'll be back. I'm gonna sit you in here and in there and make sure you see some of me destroying that tool. Okay, I'm gonna open this door, turn the coolant off. See, when the cut gets lighter, because the plate is not flat, perfect, you can hear the vibration. You're hearing it. See that? Not enough load. Chip load is not enough. And then here, where there's more chip load, it sounds better. See that? Can barely hear it. And then on that end, there's less material. See that? Now it's gonna sound the same everywhere. See that? Okay, let me out this part. I forgot chamfering that area over there, so I'm gonna go ahead and do a run from here. Run. 8,000 chamfers on it. Okay, so I'm gonna insert this part too. So these vices, even though I bought them at the same time, and I believe I already talked about it on a video, I bought them at the same time. I told the seller I want them to be from the same batch or whatever. They were like 8,000s off from whatever the surface is to the bottom, you know, pretty much the surface. I mean where it slides back and forth over there. So what I did, I took them both apart, seated them on that area where you kind of pretty much your parallels or whatever, and then face this one off. I mean, I already faced that one and DA it. So after I face it off, I move that one and put this one in, face it off, and then DA it now. It's so hopefully they both have the same height, and when I put a part on it and I put two parallels on both vices, they got the same height. This is what you pay for buying, you know, cheap stuff, but for what I do, it's fine. All right. Okay, so that's the finished product of machining the vices on the bottom to make sure this surface right here, they're both parallel, or you know, they're both the same. Zero. So now if I put, you know, a long piece and I just want to sit it on parallels here, it's gonna it's gonna be flat all through them two vices. So there were like 8,000 difference on it. So what I did, well, you saw it, sit it on this end right here and face the bottom of it, and now we can just put parallels both sides, and our part is gonna be level on the table. All right, I'll keep going. Okay, so I went ahead and surface both of the jaws support or the top of the vices at the same height, and that's what I got going on. On the money. So now these two vices, they're matched. It's a match pair. So pretty much anytime I'm gonna use them, I'm gonna use these two for a longer part, and maybe if I need to, I can always put one on the middle, but on the outer, if it's a longer part, I can put these two on the outside and another one in the middle, and I can create more support but still be lined up to the table, because these two, they have the same height here to the table and also here to the table. Okay guys, I'm gonna keep going. Okay guys, so it's morning already. Last night, like I said before, I finished the vices. I was finally able to sit the stock or the workpiece or whatever in between the vices. So I have to grind a little bit inside this vice, not this one, but here, so we'll make it back up a little bit, 1/8 of an inch, and that way I was able to fit the piece on it. So it's not set ready yet. I went and got me another set of the cheapest probably you can ever find on Harbor Freight. Parallels, because I already got a set like that. No, not here. I got a set like that, so I'm gonna have another set. I need to set two vices. So so now, oh, and I also bought this cheap cheap caliper. It's a 12-inch. It's not that it has to be really precise. It's just that sometimes just pull that thing off. Sometimes you got a big part. Is that tight? That tight? Okay. And you just want to get some idea of what it is. It may be okay, maybe close to whatever, but the idea is just to get a measurement somewhere. Like in this case, this piece right here. So it's 200 and what? 210.4. That's really close. 210 millimeters. Guys, that's crazy. That's crazy. So you know, and the one I had it was not a. You see how it's doing pretty good. The machine is doing good, and I'm not saying the caliper is perfect or the machine. Either one, but you know, if I need to measure something big like that and I don't have to be really accurate, I can just get on it. And if I want to measure just something bigger, then I will use the Pro or whatever. But you know, if you just want to have an idea, you can buy this. It's extremely cheap. It's like, I believe it was 40 something dollars, whatever. Am I gonna break it already? Yeah, I almost break it. Well, anyway, we got a bigger caliper. Oh, same draw again. Got a bigger caliper and another set of parallels, so we can set both vices at the same height. Because you saw what I did with the vices. And okay, I'm gonna stop here. Okay, so that's how it looks on the very first operation, first pass of the facing off. These studs, they're really tough on the very outer skin, if I can say it like that. That skin out there is really hard, but I mean, this is me. I never do more than 1,000 on any of my face milling processes, unless I know it's just gonna be a rough enough. But since I'm just facing to get to a flat surface, I always do 1,000 on my cam program, and then what I do, I just keep lowering my Z-axis until I get, you know, the least amount of material out of my stock, if that makes any sense. So now we just do 1,000 off, and this is all I get. So now I ran the same inserts that I was doing, devices and all that. So I'm gonna go ahead and put a new set of inserts on the face mill and lower 1,000. I mean 2,000. I'm gonna lower 2,000. I got more than 1,000 here. So I'm gonna lower 2,000 and just go ahead and run it. And I'm gonna increase my feed speed over to 100. I was doing 50. I'm gonna increase it over to 100 and leave my spindle at 3,000 RPM. So it's gonna be 40%. It was 50. I mean, okay, let me say it again. It was 3,000 RPM, 40% of 2 at 50 inches a minute. I'm just gonna go up to 100 inches a minute at the same 3000 RPM, the same 40% tool engagement or whatever. Let me stop, change my insert, and keep going. Okay, so that's 100 inches a minute right there. I'm doing 40% of the tool diameter, and that's a 2-inch face mill. And I'm going at 3,000. No, I'm going at 2,300 RPM. So kind of on the slow end of the spindle, and it sounds pretty good. I can barely hear it. I don't know if you see some chips over there on top of the material. There's no noise on it or nothing. Now, that's not a big cut at all. That's only a 2,000 depth of cut, so it's not even much. Like I said, I like to drop it, a little bit at a time, so I make sure I don't waste any material. I don't care if I have to air cut or whatever. There's some chips over there on the top. Hope you can see them. And that is adaptive milling, adaptive facing. I normally get way better results on the finish on adaptive that I do on SIG or zigzag milling or whatever. No vibrations, no. The weight covers make more noise than the whole machine is making. Then I'm gonna stop it and look at it now. That's on our next tool, pretty much. That is pretty good. Get closer over there. It's very good. See, I didn't even took the chamfer off. That's this, we were just flattening out this piece that is. But if you see, you remember on the previous video I talked about the corner radius on the roughing mills or face mill or whatever. If you look at this video really closely, on the very end when the mill was coming in, he left a small little line over there, and it went ahead and cleaned that out. I can't feel nothing other than that I was running at only 2,300 RPM at 100 inches a minute. So and you can see those machining surface over there, which I don't care. This is the top side, and I wanted to look like I machined this, and the way the machining looks. So and And the other thing is, I didn't tell you, I use aluminum inserts for this steel, and now the feet have to be higher. On my experience, if you're using when I use those let me talk about that for a second, and I'll tell you what I mean with aluminum inserts. So this is normally what is recommended for steel, right? This yellow style deal, and these are what are recommended for aluminum. Really sharpy, you know, like sharp, extremely sharp. And these are not that sharp. So you're supposed to put a longer ship load on this, I believe, than you do on this one. And that is the reason why I use the aluminum one, even on a steel, because I can always feed really kind of on the high end and get that result that you saw over there, and the insert's still good. Maybe this one will last longer, not on my experience, maybe on your guys' experience, yes. Besides that, this are a little bit higher than what these are. So I normally just use the aluminum one, like I said. Okay, so and you can always get that surface, and it does good. It's not a big deal. It'll finish good, and you will hear any noise. These are not big ships at all, because we were only cutting 2000, but you can barely hear this. It was just, you know, butter, because it's really sharp insert. All right, I'll be back. That's just some center drilling. And then we're gonna start drilling. We'll see how it goes. I don't know about the parallels over there. We're really close to the parallels. Hopefully they don't move and get to my drill. They don't look like they did. Okay, so we successfully drilled all the holes. Didn't break the tool or touch the parallels, because they're right on the very edge of that hole over there, right here. But this is what I got on my drill bit. So my speeds and feeds are plunging feed. It's not right. We gotta take care of that. Even though we have some good, but I need to break more ships, so we're probably gonna peg drill like tick tick tick. And so far it's looking good. So now we are gonna go to the main holes for the main caps, and then we're gonna start milling. here. So what I did over there, I just stopped. I hit my stop button right there, machine stop, and then I just ran over to next tool, and I'm gonna do a run from here. Then I just gotta click on the window, run from here, cycle stop. I got that drill on the drill shock, so I don't know how we're gonna do it. We're making a mess right there. A lot of shit's getting stuck on the drill bit. Maybe some shorter peg drilling. Those are 50,000, so maybe we gotta go to 25. We'll still fly off this drill bit sometime. Maybe we have to slow down that drill bit a little bit. It actually sounds better. That's 1800 RPM instead of 2000. Maybe too fast still. Let's see on the next hole. This is a learning curve, guys, so that's okay. That's not bad. Although we're building some chips over there, they're coming off. We can climb up there and check like temperature and everything up there, like on the spindle motor, maybe. think so, because nah. If I can drill that with a 1/2 inch drill bit with my hand drill, that motor can drill that hole and not get hot. That's a 3 inches a minute, plunging feet, right there. 1800 RPM. And we almost gonna be done. Four more holes, guys. 4 more holes. And next tool is the tricky one. I believe it's gonna be our 1/2 inch end mill. It's just gonna start pocketing all of that. That's gonna be scary. For that tool, I'm gonna sit you in there on the spindle. So I'm gonna stop, check all the. Okay, guys, I hope you hearing this. Anyway, so we already milled the outer contour on the X, and now we're gonna start pocketing. So I make sure I have my speed and feed the same way I programmed it on the first place, and so I did program 200 inches a minute on feed rate and 50 inches a minute on plunge feed rate, plunging pretty much. So I am gonna slow it down and see how it goes plunging, and then we'll go from there. We'll see how it goes. I really never mill, like I said, this deep, so we're gonna go the full length of the material, 3/4 of an inch, and I'm gonna try to keep it up around 150 to 200 inches a minute. So let's see how it goes, and I'm about to send it right now. Okay guys, so I couldn't make it. Almost 90% of the third hole of the third pocket, and I already messed up the tool. Everything is hot here, and this tool is, I mean the whole tool is hot. So hope you see it over there. I'm gonna change the tool and keep going. ¿Ya lo quitaste? Okay guys, so I already broke this or wore out this end mill. That was the first end mill 4 fluid. I had to change over to the 5 fluid and start from the other side. So pretty much on the third hole from the right, I mean from the left to the right, this end mill went out. I was climb and conventional milling. Right now I'm only climb milling, and I'm gonna try this strategy and see how far I can get that way. So pretty much from the right to the left. It's sounding pretty good. I'm around 6,800 RPM, 120 inches a minute, and I'm at 3% of that tool, so I believe it's around 20 thousandths, maybe 25. I don't remember right now. Anyway, so it's a little heavier cut at even lower RPM. So let's see how far we can get with that strategy over there. And we can do so only air only. Let me wait for that coolant to stop. Well, if it ever stops. Okay guys, so it's cutting good. We're already on the third hole and it sounds good too. And we are not leaving any debris on the edge of the cut, not much at all. So I think we're gonna be able to finish the whole thing with that one tool. So I'm gonna stop the video and just get back to you when I'm done with this operation. I gotta do the tool change. The tool change is to do my finishing pass, and it's gonna be done on a 3/8 so I can finish the very corners of those shapes or whatever over there, those pockets. So we are Where are we? 140 inches a minute. 68. So what this actually proves is that climb milling is definitely better than conventional milling. So I did both on the other side. I did 2% climb, 1% conventional. So you know what I mean, like the tool going on conventional cutting, it was doing 1% of the tool, and on climb milling was doing 2%. That was not enough chip load, and conventional milling doesn't work. So you do gotta make a lot more Z-axis movement, but I honestly feel like it's cutting a lot better, it sounds better. And since I'm only doing climb milling, I went to 3% on climb milling, and it still sounds good. And you've probably seen some of the colors of the ships. They're coming out kind of on the blue end. So I think we're doing good so far. I'm just gonna let it run, stop the video. It's been running for 35 minutes already. So I'm probably gonna have to cut it and speed up some parts over there because it's gonna get boring. So, but yeah, the first tool was my mistake, totally. This tool, I believe I learned something or many things today, but one of the things that I learned was that no conventional milling at all. No, don't worry about Z-axis coming out up and down. Just do climb milling all the time. All right, I'm gonna stop here and then I keep going. This was a challenge, but it came out good so far. Yeah, that's on this here. Just like this one here. The rest was fine. All the shambles are good. Finish part. A lot of material, guys. Okay. And the Haas lift through it. We got plenty of chips. I don't even want to touch it because they're sharp. But we got a ton of chips. Right there. Right. Too many. So the motor is alive. The spindle motor is alive. It didn't throw any alarms. I did broke an end mill or wear out or whatever. But I mean, I don't feel bad at all. And the spindle is just beautiful. Okay guys, so as you saw, I already cleaned the machine. I got plenty of chips on the tractor bucket or whatever. I want to say this was a challenge doing this. It wasn't as easy as I thought. I believe next time I do it, because I know I'm gonna do it again, I'm probably just gonna try to fix it or something so I can slot out the pieces and I don't have to machine that much metal, that much material out of the piece of stock. It's just sitting over there. It's not tight or nothing. But so now I just gotta hold it like the same way it is, and I gotta cut two very long areas right here, so it's pretty much gonna sink, let's say, in the block, down into the block, and it should be done when I do that. Other than that, like I said, the machine worked good. The spindle did good. The spindle motor did good. All my axes, no problems. Oh, I want to say this too. Chip control or chip evacuation. It was a mess. Like, for some time, I didn't know I was gonna say something like this. I do not like coolant. Coolant really create a lot of, it goes against chip evacuation, so it will keep the chips on your workpiece and they will not fly away from your workpiece. So I am really thinking into putting some mist coolant. So I only got air, and you are gonna see it on this video. I do got air pushing in, and I got some parts where you're gonna see that I'm just air cutting. Like cutting with air only. And so I gotta set something up over there to it will suck some of that coolant from the same line and push it through the same nozzle. So pretty much like a mist coolant. So I want to start using that. It was a real mess. Try to keep the chips away from the workpiece. I have to. It was not good. So I learned that my speed and feed, they cannot be, at least on steel, even a 3/4 of an inch, they cannot be 10,000s only. It's got to be over 20,000s. I did 25,000s. The end of the cut that I was doing was, I believe I was around 140 or 160, 25,000 depth, and I was at 6,800 RPM. So, and the whole tool did good. The tool's still over there. I didn't broke the tool or nothing. That's also a cheap tool. It's a 5 fluid, but it's a cheap tool from eBay. So it's not a really high dollar tool. It's a cheap tool. And so, like I said, I have to be around, over 20,000 for sure. Chip load is really important. And mist coolant, I gotta fix that. I gotta use mist coolant. Yes. Other than that, I'm gonna wrap the video like this. The part came out good. It's not done yet, so I'm just gonna go ahead and just finish this video for now, and then I'm just gonna do a short one on finishing and mounted it on the engine block, and then I will be ready to just build that engine. I have said this many times, and I never do, but I always want to keep better things on it. I put better things on it. So, but yeah. All right, guys. Bye.